sklearn cluster meanshift. Description: meanshift is a density-based clustering algorithm that finds regions of high density in the data and assigns points to these regions as clusters. It does not require specifying the number of clusters beforehand. Inputs: data, a numerical array or matrix representing the data points to be clustered. Bandwidth, the radius of the kernel used to estimate the density at each point. Outputs: cluster centers, the locations of the modes peaks in the density function, representing the centers of the clusters. Cluster labels, an array of integer labels assigned to each data point indicating its cluster. Membership: points belonging to the same cluster have the same label, and noise points are labeled as -1. Steps: shift points to mode for each data point. Iteratively shifts the point to the center of mass of its neighbors within the bandwidth. This process continues until convergence, where the points converge to the modes of the density function. Metrics: silhouette coefficient measures the quality of clustering by evaluating how similar a data point is to its own cluster compared to other clusters. Kalinske-Haraba's index measures the ratio of between cluster variance to within cluster variance, with higher values indicating better clustering. Visualization plots: scatter plot with cluster labels, a scatter plot of the data points, color-coded by cluster membership, to visualize the resulting clusters. Fine-tune parameters: bandwidth controls the size of the neighborhood used to estimate density. A larger bandwidth can lead to fewer, larger clusters, while a smaller bandwidth can lead to more, smaller clusters. Quantile specifies the quantile of distances used to estimate the bandwidth automatically if not provided. Uncertainty methods: probabilistic clustering assigns probabilities to cluster memberships instead of hard assignments. Challenges and fixes: sensitive to bandwidth. Use domain knowledge or visualization to estimate an appropriate bandwidth. Perform grid search or other parameter tuning techniques to find the optimal bandwidth. Computational complexity: can be computationally expensive for large datasets. Consider using approximation methods or faster implementations of the algorithm.